Right, this next video is about completing the square. So completing the square just means we are rewriting the quadratic into a different form, what we call the completed square form. So it just means rewriting the quadratic of this form, what we're used to, into this form. Now you should notice we've gone from having two x's in the equation, expression in this case, down to just having one x. Now this is useful for numerous things, but the main one for now is just solving them. So it's called completing the square because we put it into a single bracket squared, and then we'll just have to mess around with this number outside to make sure it matches up with this number if we expanded it. So if we just have a look at expanding these brackets, x plus 3 squared, expand it, we'll get x squared plus a 3x plus another 3x plus a 9, giving us x squared plus xx plus 9. In this one, we'd get our x squared, we'd get a 5x and another 5x, giving us 10x, and we'd get 5 times 5, 25. On this one, similar, we'd get an x squared, we'd get a negative 4x, another negative 4x, give us negative 8x, and negative 4 times negative 4 would be positive 16. So, what do we notice? First of all, with the coefficient of x, what do we notice there? Hopefully we notice that it's always double this one, double this number in the brackets. 2 times 3 is 6, 2 times 5 is 10, 2 times negative 4 is negative 8. And the number at the end is always this one squared, 3 squared, 5 squared, 4 squared. So if we had a square number there, then we'll be able to factorise into a single bracket. But completing the square is not about factorising, otherwise we'd just call it factorising. So, as we've just seen, we go into a single bracket when we're completing the square. We have a single x and the squared goes outside the bracket, it's the bracket squared. And as we just saw above, the term in the bracket is always half of this one. So we half this term, this coefficient, and we put it in the bracket, x plus 2. Now, if we expanded this bracket, we've just seen you would get your x squared, you'd get your 4x, but the number at the end, the constant term, would be this squared, it would be a 4. So the constant term at the end would be 2 squared, is 4. But we don't want it to be a 4, we want it to be a 7. So we're going to have to add an extra 3 in order to change this 4 into a 7. And that's it. This has now been written in completed square form. This is just some working out. This is our answer. X plus 2 squared plus 3. So it's just a case of halving this coefficient in the bracket, asking yourself what you would get if you squared it, and then adjusting that afterwards to go back to the original constant term at the end. Okay, so same thing on this one. It's an x, bracket squared, half this coefficient, and then you can do this bit in your head. We know what 3 squared is. 3 squared is 9. So we will, if we expanded this bracket, we would have a 9. We don't want 9, we want 4. So we'd have to subtract 5 off that 9 to change it back into this original 4. And that's it. That's in completed square form. Same thing here. Bracket squared, single x, half this coefficient. Then consider what would we get if we squared this out. We'd get a minus 4 squared, which would be a positive 16. Positive 16. We wouldn't want 16, we'd want 10. So we'll have to subtract 6 to take us back to that original 10. That one's done. Last one. Looks a bit different, but we still follow the same process. X in a bracket squared. we still half this coefficient. We still consider what we would get if we squared this out. We'd get our 2 squared is 4. But in this case, we don't want anything afterwards. There's no constant term, it's 0. So we'd want to get rid of this 4 entirely. So we subtract 4. And that's it. That's in completed square form. Now, those were the straightforward ones. What you may have noticed there is that the first, just go back, the x squared term had no number in front of it. Okay, that first term was 1. When that isn't 1, when the a is not 1, there's just a little bit more work to do. And in this case, it's going to look slightly different in completed square form, and there's going to be this extra number now in front of this bracket. So, here we have this number here, we've got a 2 instead of a 1. So, the best thing to do is, because 2 goes into both of these, it doesn't go into 3, we would factorise 2 out of those first 2 terms. But leave the 3 alone. So that's not completing the square yet. I've still got the 2 x's, the x squared and the x. I've just factorised this common factor of 2 in front of this bracket. We now do the completing the square step. So single x in the bracket squared. We still half this coefficient. Half of 2 is 1. However, now whatever comes out of this bracket will get multiplied by this 2. Will get doubled. So, an extra bit of working. This time it will be 2 lots of 1 squared. Which will be 2. So out of this lot, we're going to get a 2. We want it to be a 3. So I have to add 1 to change it back to that 3. And that's now done. That one's in complete the square form. We have our 3 values. P is 2, Q is 1, R is 1. So there's just this extra step here at the start. So similar here, we've got a 4 here, so we're going to have to start by factorising a 4 out. And again, it goes into this, so I'm going to factorise out to that. It doesn't go into the 11 though, so I'm going to leave the 11 alone. Okay. So that's not completing the square, remember, that's just factorising. Next step is completing the square step. Single bracket, single x squared. Half this coefficient. And then we're going to have to consider what comes out of this to decide what goes on the end to take us back to this 11. But remember, whatever comes out of this bracket is going to get multiplied by this 4. So out of that bracket, we're going to get 4 lots of 3 squared. 3 squared is 9. 4 lots of that is 36. So we need to take this now from 36 back down to 11. So we're going to subtract 25. And that's now in complete the square form. Now this next one, I'm going to do slightly differently. I could do it in exactly the same way, but because this is a 5 now, and 5 goes on into all 3 terms, I'm going to show you that you can do it by factorising the 5 out of all 3. So, factorising that. And now I'm going to complete the square on what's inside the bracket, which is more like the ones from the very start. So we're going to get a bracket within a bracket. Okay, we still have to half this coefficient. This time, because this 5, I've put it outside all of this, I'm completing the square on what's inside here. I don't need to worry about times in by 5. I just need to think 2 squared is 4. I need to change this 4 into a 7, so I've got to add 3. What I can now do is expand the big square bracket to put it into the form I want to complete the square form. 5 times that and 5 times 3 is 15. So that's another way of looking at it, another way of approaching it. I chose that way only because the 5 went into all 3. I could still have done it using this other way. I only factorised the number out of the first 2 and sorted out the number at the end last. Okay, last 2 are all about negatives. So there's no number here, apart from that it's a negative 1. So I have to factorise that out. Negative. I'm just going to factorise out these first 2, like most of the others. X squared plus 4 now. I've left the 10 alone. I'm only dealing with these first 2. So I'll factorise that negative out of these first 2 terms, making them both positive instead. Now they're completing the square step. Half this coefficient. Now, whatever comes out of this bracket is going to get changed by this negative. So it's going to be a negative 2 squared. So we're going to get a negative 4 coming out of this. We want to change that negative 4 into a 10. So we would have to add 14 to it. And that's done. That's in the complete square form. Last one is similar. Now, we normally like to have the x squared first. So we could just rewrite that. So the x squared is first. Then the x term. And the constant at the end. And then I'm going to do this in exactly the same way as I did the previous one. Factorise a negative out of these 2 terms. So that will now become a negative 8x. Negative 2 is going to stay as it was. So that's just factorising, that's not completing the square yet. That happens now. So we halve this coefficient to give negative 4. Whatever comes out of this bracket is going to get multiplied by this negative. It's going to be negative 4 squared, which will give me a negative 16. I want to move from negative 16 back up to negative 2. So we'd have to add 40 onto that one. And that's in complete the square form. Okay, so that's 2 situations. One where the a at the start is a 1, one where it's something else, a number or a negative. Now, perhaps more tricky is when the b term, so when I'm talking about a, b, and c here, I'm talking about, well, we've got it in the form of ax squared plus bx plus c. When all the ones previously, this term has been an even number, which is nice because we're halving it. If it's not an even number, we can still complete the square, but we have to be extra careful because we're going to be dealing with fractions or decimals, whichever one you like. The process is still exactly the same though, just extra care. So here we have an odd number, we have a 5. It's still exactly the same. Single bracket squared. We're halving this term. So it's usually a lot nicer to work with fractions, especially when we're squaring it, because we can just square the numbers in the fraction rather than messing around with the decimal. So the next step is exactly the same. We're going to square this. Pi over 2 squared gives us 25 over 4. Now, what might be easier now is rather than thinking how do we get from this to 3 to decide what comes to third, is just keep the 3 as it is, and then think, well, we've got this extra 25 over 4 now, which I don't want, so I'm actually going to get rid of that. So I'm going to take 25 over 4 off this 3. And you do that however you like. You can either change this into quarters or change this into a decimal. So this would be 6 1/4, so take off 6 1/4. think of this as 12 quarters, take off 25 quarters. Minus 13 quarters. That's in completing the square form. We may want to simplify this. We may want to write it as a proper fraction or as a decimal. Always check what form the question wants you to write the answer in. That'll do for this one. So, same process, just perhaps a little bit of extra care needed because we're dealing with fractions now. Okay, so same thing here. Half this coefficient, negative 3 over 2. We're going to have to think, right, what's that squared? Give us a positive 9 over 4. And as I said, it's probably easiest to think to just keep this 4 and get rid of that 9 over 4 afterwards. So this is 16 quarters, taking off 9 quarters. So I'll end up with 7 quarters remaining. So that's in complete the square form. Now we're going to have both situations going on where they've got this. We've got this A term now, and we've got an odd number to deal with. So even more care needed. So let's deal with the 3 first. We have to factorise that out of these first 2 terms. So let's deal with the 3 first, and we have to factorise that out of these first 2 terms. Keep that 7 as it is. Okay, that's just factorising. Next steps to complete the square step. Half this term, the fraction 5 over 2. So again, I'm going to keep this 7, and we just need to decide what goes on the end. And that's whatever's coming out of this bracket, but now is multiplied by this 3. So out of that bracket, we're going to get 3 lots of 5 over 2 squared. So that's 3 lots of 25 over 4. So that's 75 over 4 that we need to get rid of. So we're subtracting 75 over 4 off there. So this first bit doesn't change. So this is negative 28 over 4, taking off another 75 over 4. Takes us down to that. And that's in complete the square form. We may just want to simplify that. I'll write it as a proper fraction. Okay, similar thing here. So we have to start by dealing with this 2. This is just the factorising bit, so this is going to become a 5 over 2 from the factorising, that's before we half it. So we've only factorised at that point. Then we do the completing the square bit. So we have to half this term. So we don't write it as 2.5 over 2. If we half this, then the bottom becomes a 4, the bottom becomes doubled. So that becomes 5 over 4. Plus 3 is going to stay the same, and then we'll just see what comes out of this bracket to get rid of. So we're going to get double 5 over 4 squared. So 2 lots of 25 over 16. If we double this, the denominator gets halved. So it's 25 over 8. So that's what we're subtracting. So it's 2 x plus 5 over 4 squared. This 3 is 24 over 8, taking off 25 over 8. So we'll end up just negative 1. And the last one just brings together all of that and adds in the negative. So our first step is to deal with the a term. So we factorise that. After these first ones, this will become plus because we factorise out a negative 3x plus 1. So that's the factorising. Next step is completing the square. Halving this coefficient, again it's the bottom that gets doubled then. If we're halving thirds, we get sixths. Keep the plus 1 for now, but decide what we need to subtract off it, what we need to get rid of, and it's going to be multiplied by this negative 3. It's going to be 5 over 6 squared. So negative 3 times by 25 over 36. Timesing this by 3. That's the same effect as dividing the bottom by 3. So we'll end up with negative 25 over 12. Subtracting off that. So, final answer. This is 12 over 12. We're taking off 25 over 12. We'll end up with negative 13 over 12. That's that one in a completing the square form. Right. One use of completing the square is to solve quadratics that potentially are difficult to factorise. If you can't factorise them or are struggling to see how they factorise them, then completing the square could be the way to go to get our solution. So this first one could factorise, but we're going to do it using completing the square to show how that would work. So it's a simple one. We're going to go straight into completing the square, no factorising needed. We'll just half this term. And then 2 squared is 4. We need to change that into a 3, so we'll subtract 1. Now we've got it equal to 0 because we solved it. And now we just need to solve it. Rearrange this, make x the subject, and we'll have solved it. So we'll do it a step at a time. Feel free to skip steps when you're confident. Add 1 to both sides. Next step is to square root. Now, when we square root 1, we don't just get 1. Remember, when you square root anything, you will get a positive and a negative answer. And we write that by doing a plus and a minus. So when you square root 1, you get plus or minus 1. Then we subtract 2. And we normally write that bit first. We've got this plus and minus thing just so that we can see that it's only the 1 that's got the plus and minus on it. There's nothing after it's got a plus and minus on it. Now, sometimes that's our final answer. But because we can actually do this, we know what minus 2 add 1 is. Minus 2 add 1 is minus 1. And we can do minus 2 take 1 for the other solution. Minus 3. Okay, so we've got nice whole numbers for that one because it would have factorised. We could have factorised this straight away as x plus 1, x plus 3, which would have given us the same solutions. But that's for showing the process of completing the square. This next one won't give us such nice solutions. Here, difficult to factorise. Numbers that multiply to give 19 will just be 1 and 19. We can't make those add up to 10. So completing the square could be the way to go. Okay, so we're going to straight into it because there's no number here. We just need to half this term. 5 squared is 25. We need to change that 25 into a 19. So we'll just subtract 6. That's complete the square done. Now we solve it. Again, we'll do it in every step. Add 6 to both sides. Next step is to square root. So again, we get plus and minus, but since I don't know what the square root of 6 is, we'll just use the third, root 6. Next, add 5. And as I said before, we normally write that bit before. 5 plus and minus root 6. And that's our answer in exact form, which is what you're generally asked for. If surds are involved, we want to keep them exact, so we leave them as surds. Or it could ask you to work this out as two decimal places or 3 significant figures. So you'd have to do that in your calculator. 5 add root 6, write down your answer and round it. 5 take root 6, write down the rounded answer. Okay, next one, we have this A term. So first step here is to factorise the 2 out of these first 2 terms. Okay, so that's factorising done. Then we complete the square step. Half this coefficient. Minus 1. Then whatever comes out of this bracket is going to be multiplied by this 2. It's going to be 2 lots of 1 squared. So we're just going to get a 2 out. We don't want a 2. We want a 1. So we subtract 1. Oh, I missed my square off. That's completing the square done, and then we solve it. Make sure you do things in the right order. So we would add 1 first. Next step is to get rid of this 2. We can't square root yet until the thing that is squared is on its own on this side. So the next step is to divide by the 2. Space. Next step is to square root. So the square disappears. We square root this, or we square root the 1. Square root of 1 is 1. Square root of 2 though, still with these plus or minus. Final step is to add the 1, which I would put before it. And that's finished. That's in exact form, that's in third form. Again, if you want it as a decimal, you can put it in your calculator. Your calculator might give you this looking slightly different. It'll give you it as root 2 over 2 because it will rationalise the denominator. But there's nothing wrong with this that we've got here as an answer. Final one, negative. So we need to factorise this negative out first. So we end up with a 3x as the second term. Leaving the 3 alone for now. Completing the square step. Half this term. Then, as I said before, when you're dealing with negative, the fractions, it's often easier to leave the 3 there and then deal with what comes out of the bracket by subtracting it afterwards. So out of the bracket, we're going to get a negative 1 times 3 over 2 squared. So that's negative 9 over 4. So we need to get rid of this. So we would add 9 over 4. So I might just simplify that before I start solving. This is 12 over 4, add the 9 over 4. 21 over 4. Okay. Now to solve this, I could subtract the 21 over 4 and then divide by minus 1, or I could add the bracket instead so that both things become positive. I'm going to do it that way, but I'm going to keep the thing I'm looking for on the left hand side. So adding this to this side would make it into that. Next is the square root. I know what the square root of 4 is, but not the 21, so that's the bit I will leave as a third. So plus and minus root 21 2. And finally subtract the fraction. I'll write that first as subtract 3 over 2, plus and minus root 21 over 2. And we may be happy with it in that form. Since they both have 2 as a denominator, we might want it as a single fraction. Or we may want it as decimals, in which case you'll need to use a calculator. Okay. Final thing, if you just pause the video, have a go at solving these using completing the square. So go through the process, complete the square, and then go through the solving process. And unpause once you've had a go. So you should find that you get an error. That's because when we complete the square, 2 squared is 4, we want 7, so we add 3. Now when we're solving this, we end up with a negative 3, which we would then want to square root. But your calculator will tell you there is an error, because we cannot square root negatives. In the numbers we deal with, we're dealing with what we call real numbers. We don't have any square roots and negatives. That's why we have to bring in complex numbers, which is something we deal with. So when you end up square rooting a negative, we say there are no real solutions. So there are no real solutions to this. And we'd get the same here. 3 squared is 9, so we'd add 1 to get 10. So we're going to end up trying to square root -1. So again, no real solutions to this. Okay, so you cannot square root a negative ever. Some quadratic cannot be solved. Completing the square is still useful for other things. Okay, but you can never square root a negative. So we have to stop at that point and just say that there are no real solutions to that problem. Okay. Have a look at these two exercises then, and when you're ready to move on, have a look at the next video.